Welcome to Computer Programming with Sharon. Today we are going to discuss about the collections and map in Java. With example, we will explain how to use it and the difference between different collection classes and map classes. If you are comparing collection and map, in collection it's a collection of different objects without any specific key. Some may contains some index values and other may not. But in map, all the values will have a specific key. If you are taking collection interface, different interfaces are there. List, queue, Deque, set, sorted set. In list, it's an ordered collection which follows the index based. Like its value we can retrieve using or we can remove using 0, 1, 2, 3 like that, the index value. It will allow to insert the value, update the value, delete the value and search the values. ArrayList, LinkedList, vector and stack are the classes implemented by the list. If you are taking queue, then again it's an ordered list which follows FIFO, first in first out, like a queue in cinema theater, inserting limited in the end. We can see like the values will be added to the end of the queue only, or the new people will come at last, and deletion limited from the start. From a queue, first person is treated first. PriorityQueue is the class implemented by the queue. Then Deque is coming, it's a subset of queue only, but here it's a double-ended queue, that's Deque. So we can use for FIFO or LIFO using the Deque concept. First in, first out or last in, first out. Both are possible inside a Deque. So addition and removal permits in both ends of a Deque. ArrayQueue is the class implemented by the Deque. Set, it's an unordered collection and which do not allows duplication. In others we can have the duplicated value, but in set it will not allow. HashSet and LinkedHashSet are the classes implemented by the set interface. SortedSet is a subset of set. The elements will be added in a sorted manner. Otherwise, it's like a set itself. TreeSet is the class which is implemented by the sorted set. As I said, inside the list, 4 classes are there: ArrayList, LinkedList, vector and stack. The difference between these 4: ArrayList, it's using dynamic array to store the element, but there is no size limit specified over there. And again, it's non-synchronized, or we can say not thread safe. If multiple threads are trying to access a array list at a time, only one thread can modify this one. That's why it's saying non-synchronized or unsafe thread. Manipulation is slow because of the array concept. Linked list, it's using doubly linked list. So there is no array concept over there. Memory space can create easily in different places and it will connect it to other. So if you're comparing with the array list, it's very fast. And here it is using Deque. Vector, it's a replacement of actually array list. It's a synchronized dynamic array and will have all the properties of array list. So it's a synchronized, that means it's a thread safe, multiple threads can access at same time. Stack, which is following stack methods, that is LIFO, last in first out. The main operations are push and pop. Using push we will add to the top, and using pop we will remove the items from the top itself. For example, if you are placing the plates, stack of plate, we can add on top of the stack only or top of the plate stack and can remove only from the top, not from the bottom. So same thing will happen there. In set, 2 types of classes were specified there: HashSet and LinkedHashSet. In set, instead of indexing, it's using hashing mechanism to store the elements. In HashSet, it's not keeping any insertion order, and of course it's a non-synchronized. Only the difference between HashSet and LinkedHashSet, in LinkedHashSet the insertion order is keeping over there. Then we have map interface. We have 2 types of interfaces are there: map and sorted map. Using map, key should be unique. We have two classes in Java, HashMap and LinkedHashMap. And TreeMap is the class implemented by the SortedMap interface. HashMap, LinkedHashMap. These are the classes which implemented by the map interface. Only the difference, HashMap doesn't maintain any order for the key values, but LinkedHashMap tried to save the insertion order. Now with example, we will see one by one classes from collection and map. First we will start with the collections, and from the collection first we'll give the example for list. ArrayList example.java. All the collections are from the util package, so it's imported over there. Here we have to know the generic concept also there. This angular bracket, it's for the generic concept. Normally if you are not giving this less than, greater than, or that diamond shape bracket, then we can save any type of data types inside this array list. So it can be an integer value, or it can be a string value, or any other object. It will not show any error, and of course we can access using printing statement. So this is not an error, but if you want to keep same data type there, because if you are keeping different data types in a collection, then it will be difficult to handle. So if you want to keep only same data type over there, then use the generic concept over there. So to keep the generic concept, you have to specify the data type over here. It should be some classes. It may be a customized user defined class or a built-in class. You can't say just like int or float. You have to specify integer or float or double, that class names here if you want to save some numbers over there. And right hand side, either you can keep empty diamond bracket, or you can specify the data type over there. So this is not compulsory over there in right hand side, but left hand of course you have to specify. Now this is showing error. If you are trying to run, of course it's an error only, because it will allow only the string type now. Now I'll try to save some string values there. We'll keep some names over there, say Anu, Manu, Alan, Sham, Geeta, and just print those values. We can see that it's saved over there and printing those values. So if you're trying to print an object, then also you will get the output properly. You can find out the elements saved inside, because these are integer values only, so it's easy. But if you are saving object, then of course you have to use the iteration concept, and one by one you can have to access, and you have to do the printing method over there. Now other methods inside the array list. While adding, you can specify the index value also. For example, in second position I want to insert some name. So like that, like this, you can insert the values over there. And if you want to remove some values, you have to specify the index over there. Anyway, after inserting, I'm just printing the values there. Then trying to remove some values there, a dot remove. We have to specify the index over there, or we can specify the object name, that string itself. So if you are giving the string then or object, then you will get a return type as boolean. Here I will prefer the index value. Second item I am trying to remove from there. So we are removing the second item. So removed item. So this is the index value. So we are trying to remove the second item from there. We will try to provide the index value. And if you just want to access something, then you can use get method over there with index value. So just imagine I want to access the third index value. So we are not removing that one. We are just accessing those value. After the removal, if you are trying to print, you can see that that is removed from here. But here it is not removing. It's just retrieving the third index value. That's all. Now if you want to iterate one by one, you can go with the for each type loop. These are the string collection. So I can use the string data type. Then just give that array list name. Then from the X you will get the value one by one. So we'll print in a straight line with some spaces. Now run and check the program. So here all the value and in one we are adding dam, so it's a second value, it's added over there, and the second value we are removing, so removed that value. This is from 1 only, not index value is 1 actually, so I'll run it again. Okay, now so ram is removed from there. Then sham is the third index value, 0 1 2 3. Sham is the third index value, and we are retrieving that value, but it's not removing from there. Then one by one value we are accessing. Next we will check with the linked list example. Again, it's using the generic concept, so I will use the string values. The same code I am copy pasting inside this one. All these things are supporting over there. So if you are running and checking this, you will get the same output over there. Now, other than this, here you will get a function called add first, because here it is implemented by the Deque. So here I'm adding 1, and at last also is available over there. I'm adding 10 over there, and if you are trying to print those value, you can find out these will be inside the list. Now we will try to remove the values also there. Remove first is available over there. Remove last is also there. So we can operate from both the ends. Here removing first, then removing the last item. We'll try to print the all elements again. Run and check. First one is removed, last one is removed. Balanced item. And we have the methods for get first and get last is also there. So this is the first item and this is the last item. But this is not removing any item. It's just retrieving the value but not removing. So here you can see the first and last values, but it's not removed from there. Now we will try with the vector. It's same like ArrayList only. So you can go with the same example of ArrayList. From the ArrayList, I am copying the same thing over there. So we are getting the same output over there. There is no difference. Now the next one, we have to check the example for stack. So we created a stack object over there. Items will add the same thing over there. As we discussed, inside the stack, it's following the LIFO method, last in first out. The main operations are push and pop. So those we will check over there. Inside a string value, popping a value over there, a dot pop. Now we'll check the pop value. After that, we have to check the collection again. Then we'll try to push some values over there and we'll print again. And one more thing, we'll try to use the peak value, or we can say it's a top value, but the function is given as peak. I'm printing the peak value and check whether it is removing from there or not. Run and check the program. All the values are inputted over there. So all the values are there. Then the top item, that is Geeta, it's removed out from there. Then we are adding someone that is added in last position, and the last value or top value is Manoj itself. So this is a stack operation. Next we will check for the example for priority queue. Priority queue example. Here we have to add some values over there. We'll add some fruits. Now we'll try to print. Okay, if you're trying to use the priority queue, then it will automatically sort the items also, and we'll check which item is removing from there. So this, see this, the top item is, the first one is removed there, like in a queue. We will check the pick and poll methods also there, is equal to. So we are printing the peak item and poll item. After each pick and poll, we will try to print the all elements over there. We will run and check the program. Here these are the items. It's already in sorted order. Then first item is removed. Again started the sorting. So here the top item is blueberry. Pick is not removing the item, but poll is removing the item. Next we will see the ArrayDeque example. ArrayDeque. Then we have to add some items over there. We'll check and print how it's added over there. It's maintaining a insertion order. Now we'll try to find out the first and last element. A dot get first, a dot get last. So first element is printing over there, last element. Then we are printing the all collection. Then we have the remove first and remove last. Remove first is there, remove last is there. Again, we will print those elements, but here it will modify it with removed. Then last item also. Then after that we are printing that array again. Then we will try to add some elements in beginning because it's a Deque concept. In last also we will add some elements and we will print all the elements. Check the output. Elements are already added over there. First element is orange and last element is apple. But it's not removing, it's just retrieving the value using the get first and get last. Then remove first. Of course, it's getting the same values over there, but the items are removed from the array. Then add first. We are in the beginning, we are adding a blueberry and last in blackberry. So it's already there. Now we will check an example for HashSet. So there is no index keeping over there. It's creating a hash value to maintain the order. So first we'll create a class over there, HashSet eg.java. HashSet. We have to add some values over there and we will print over there. Check how it's adding over there. So it's creating its own HashSet values and not keeping the insertion order. Now we'll check the methods inside that. We don't have that remove with its index value and add with index value. You can remove the item by giving its object value. And of course, like in LinkedList, you can iterate values one by one. Here I'll try to remove some item a dot remove. I'm removing the value ln. So if ln is there, then we should print removed ln. Otherwise, no need to, and print all the values once again. So ln is removed there. It was there. Now we'll see in an example for LinkedHashSet. And there also we will give the same code over there. So first create a class LinkedHashSet, copying the same thing from the previous one. Running again. This one is keeping the insertion order and HashSet is not keeping the insertion order. Only that's the difference between HashSet and LinkedHashSet. Now we will see an example for TreeSet. TreeSet is implemented by the SortedSet, so it should be sorted over there. We'll just check. We'll add some values and we'll check whether it is sorted or not. Of course, it's sorted based on these values. Now we'll see other methods also there. We have the method to access the first and last. So we'll just try to print those value. It's not removing the value, just printing those values or retrieving those values. We can just cross check whether it is removed anything. Then here only the remove is there, but poll first and poll last is there. Poll first and poll last is there. So I'll just print poll first, poll last. Need to print the all collection elements. Now we will run and check the value. So first element, last element, using first and last. It's not removing, but the poll is removing those values. Now next we have to check the map examples. Map will always have keys and values. So we will check how it will create. First I am trying with a HashMap. So need to create a HashMap. Again it's from the util package. We have to give the data type for key and value. Only class names are allowed over there, not primitive data type like int, float, char. These are not allowed, but you can give integer, float, double. That those class names you can give over there. Okay. Now we will add something over there. M dot. Here to adding value, we have a function called put, and we have to give some keys over there, then values. So 1 I'm giving as a key and giving some fruits over there. So we will add more items over there and we'll cross check. This will not allow the key duplication. So if you are duplicating the value also, it should not allow over there. Now we'll cross check the values inside this one. Just print object name here. There is no insertion order for this one, but there's 2. It's not repeated over there. Which 2 is showing over there? The second one. So first one is actually replaced. Duplication is not allowed over there. So the first one is removed from there and replaces with the. So it's like an updation. Now we will try to retrieve some values using the key. So string s equal to m dot get is there. We can retrieve, okay, I'll retrieve the fifth value 5. 5 is giving s value, and we will check whether it is removed from there or not. We will check with the remove method also. In remove, we have to give the key over there. We will remove the fifth value. So here removed. Again we'll try to print the entire collection. So here fifth one is banana, and it's not removed from there, but here it's removing there using the remove function. Now we will try to print separately the keys and values and key pair values. So first I'll print all the keys. We have to iterate all the keys. So a method is there called keySet. This will iterate all the keys, and need to print this. We'll use the print and we'll print the key in same line itself with some space. Same for the values. We'll just print all the values. Here we have values method is there. Now key and value. We'll try to print. Key is already printing over there. Now to get the value, we have to use the get method over there and give the key over there. Now print this. We can see all the keys. These are the keys, and these are the value and key value where we are printing one by one. Now we will check with the LinkedHashMap. So same thing you can take over there. So I will just take the copy of this much. All the operations what we have tried inside the HashMap is available in LinkedHashMap. Only the difference, it will try to maintain the key order. So creating a new class over there, LinkedHashMap eg dot LinkedHashMap eg dot java. Create a LinkedHashMap key. Now we'll just check. Here this is trying to keep the insertion order over there. Now if you're seeing the output 1 2 1 3 2 5 6, the insertion order is keeping over there. The other functions are same like HashMap. So if you want to try, you can go with it. The iteration, all the things are same, so you can try yourself. Now we will check with the TreeMap. So it's working also same thing, but the keys will be in a sorted order. So we'll just cross check TreeMap example.java. So I'm just pasting the same values over there and checking the key value only. Alphabetic order it's taking, right? If you are taking alphabetic order, F, O, S, T, T, like that it's going over there. Here T are same, so second letter. So we can say it's lexicographically it's sorted over there. So based on the key, this value is sorted. Other than that, you can work with all the HashMap methods will work over here. So you can try the same thing. I think the idea is clear. How to work with collection, how to work with the map classes, and the difference between different collection classes, and the difference between the map and collection. If you have any doubt, please put in comment. If you like the video, please press like button. Subscribe the channel if you are not subscribed, and share with your friends. Have a nice day. I'm winding up for today.